Okay, so for each of these problems, I do expect you to read the problem, maybe pause the video before we get started so you know what's going on in each of these problems, and then we'll get started together. So go ahead and pause the video and take a second to read the question. Okay, so to get started in this problem, you know that we have a savings account that's earning interest. We're given a formula that represents the function. Okay, the balance B, this is our this is our function value. I'm just going to highlight that. This is our function, whereas the number of years since we've started the account is given t is our independent variable. We use that as our input, independent variable. We use that as our input into the function. So when you are trying to use the calculator to turn a formula into a table, what you have to do is use your y equals button and enter in the function into y1. So we have our y1 is equal to 1400. Your numbers might be a little bit different. I think that WebAssign will switch up the numbers in each problem and between each student. So in my case, I have y1 equals 1400 times 1.05 raised to the x power. Okay, I'm just going to make that clear. That's multiplication. Notice that we've gone from b and t in the given problem to y and x. That's because the language of the calculator is to use y and x. Y in this case is representing b, so y is the function values, and x, that would be t. Those are our input values. Those are our independent variable values. So once you've already got that into your y equals, we're going to generate a table using the calculator. The notes from section 2.1 are where we learned how to generate a table from a formula, but we'll go over it here now so you have it as a live example. We're going to press second window. That takes us to the table set, so I'm going to write that out. We're going to press second window. This is going to set up an automatically generated table for us, but we have to tell the calculator how we want the values to be generated. I want my table to start at t equals 0. That t equals 0. The problem gave us that information. Then I need to see how I want my table to change. Okay, so your table start, TBL, start, that's where our table starts at 0, and I need my triangle, TBL, this means change in the table values, to equal to 1, because look, we're going from t equals 0 to t equals 1, from t equal 1 to t equal 2. We're adding 1 every single time. So the change in our table values need to go up by 1. Once you have 0 and 1 in those locations, you can leave the independent on auto, you can leave the dependent on auto. We'll learn more about that later, but you don't need those skills right now. Now you're going to press second graph. You'll be able at this point to view the table that you've just generated, that second graph, and the table pops out. You have a list of x values, you have a list of y values, and if you're following along with my numbers, you would see x equals 0, then 1, then 2, ... It would keep going. My y values start at 1400 when x is 0. When x is 1, I have 1470. When x is 2, I have 1543.5. Okay, so now your job is just to go fill in the values from your y column, which is, as you recall, is your b column, the balance of the account, and you're going to put those in this column of the table. So for me, I'm taking 1400 and I'm popping that in the first table value. The second table value, when t is equal to 1, my balance is 1470. So just to keep it in context, my account balance starts at $1,400, and 1 year later, I have $1,470. So that's an increase of $70. You should be able to complete the rest of this problem on your own. Okay, so the next part says we need to buy a home entertainment center that costs $1,700. So we need to save up money. Remember, we only start this problem with $1,400. We need to save up until we have $1,700. So what I want you to do is direct your attention back to the table. My table, I filled in all the values that I needed to answer part B. Your table should be completely filled out at this point. What I'm going to do is locate in time where I finally reach $1,700. I don't have it after 1 year. I only have $1,470. I don't have it after 2 years. I don't even have it after 3 full years of saving because I only have $1,620. But after 4 full years of saving, I have $1,701. That means I have more than $1,700. So my answer here would be 4. It took me 4 years to save up $1,700. That should be all for number 1. All right, this is where you're going to pause the video to make sure you understand the question, the problem context, and the relationship between S and A. Once you understand it, come back and we can get started on the problem. Okay, so we'll jump right in. Using a scale from before, we're translating our function of S and A into calculator language, which would be Y and X. So let's make a note here that S is being represented as Y. This is just for later when we come back to talk about it. And A is being represented as X in our calculator. Those are just the generic variables that the calculator uses. You can see how I've entered it in 3 times in parentheses X to the 0.3. Now, if you've been using the sort of X squared button on the calculator, because you've only had to do squares so far, this is where you're going to start using the what's known as the caret, and that's this button right here, okay? It looks like a triangle without a base. It is located directly below the clear button. This is how you create exponents in your calculator. So I want you to go ahead and enter that function into your y equals, and then meet me in the table set, which is second window, and I'll talk about how to set up your table. All right, hopefully you're in the table setup window now. Pressing second window will get you there. The difference here is that our independent variable in the table is not starting at 0. That's going to make a big difference is what we do in this particular step. So again, all we did was press second window. That's taking us to TBL setup. Okay, that's table setup. So if you look at the first value in our table, you can see that it starts at 6,000. So our TBL start, our table starting value for our independent variable is actually going to be 6,000. Imagine if we started at 0 and we were trying to count by ones. It would take us forever scrolling through this calculator to get even to the first table value at 6,000. The difference in this table, another difference in this table is, let's look at between. We're not growing by 1. It's not like we're growing by 1 year like we did in problem 1. We're growing by 4,000 square miles. Okay, so this time the change in the table is equal to 4,000. Whoops, I have an extra 0 there. Now you can generate the table to get your answers for part A by pressing second graph. When you see my screen next, I'll have all of my values filled in there, and then we'll talk about part B. Okay, so all of the values in my table are filled in, and you should notice that I've rounded to 2 decimal places because that's what was specified in the problem here. Okay, so once you have your table filled in, you can move into part B, which says explain in practical terms what S of 26,000 means. Part B is testing whether or not you understood the context of the problem. So let's go back and see. We'll make some notes before we fill in the text box here. S represents the number of species of amphibians and reptiles on an island. Specifically, the number of species on that island depends on how big the island is in terms of its area in square miles. Okay. So once you've labeled what S and A are, and you know that S is a function of A, you can start to talk in practical terms. Back in context is what that really means, is to use the context, what S of 26,000 means. S of 26,000, this refers to the number of amphibians, or number of species, on an island with an area of 26,000 square miles. 6,000 square miles. You could go on to specify exactly what the number of species on that island would be because it's in our table. Okay, I'm going to use a different color to continue this answer. Okay, S of 26,000. This is very similar to the type of problem that you've seen on a quiz before. S of 26,000 from the table is equal to 63.33. What that tells us is that there are about 63 different species on the island of size 26,000 square miles. That's how you explain in practical terms what this in functional notation, what it actually means. All right, this is number 2, part C. I have seen people getting this wrong, so I want to make sure we go over it. Use functional notation to express the number of species on an island whose area is 8,500 square miles. I wrote the formula right above since I've switched pages. Now, area is in square miles, so I know this is an A value. The function is S, right? S is a function of A. In practical terms, the number of species on an island depends on the size of that island. Okay. So what we're trying to do is take our S formula, figure out what input value is this problem trying to get me to consider. Okay. In this case, this problem is trying to get us to consider S of 8,500. It's asking us how many species are on an island that is 8,500 square miles, okay? And we could calculate that value. We have the formula, so of course we can calculate that value. 3 times 8,500 to the 0.3, right? Anywhere I see an A, I'm substituting in a value of 8,500. So for the first part here, just underline that, that's what we've inputted. For the first part here, we have S of 8,500 because this is not multiplication between the S and this set of parentheses. This is an indicator of functional notation. We say S of 8,500 equals 3 times 8,500 to the 0.3. Okay. To calculate that value, we're just going to follow what this calculation formula says. So in your calculator, take a second to compute this value and see if you get what I got. Okay. Part D is more conceptual. We need to think about what's going on with the data, with this function, the relationship here, okay? It's asking in particular, is the graph of S expected to be concave up or concave down? Well, I want to draw a picture of concave up, and I want to draw a picture of concave down. We just talked about this in class in section 1.3 with graphs. So this is kind of connecting across different sections here. So we're going to take a second to talk about it. You should have the table of values that you generated right in front of you so that we can talk about this more clearly. Now, if you look at your table, you can see that as A gets bigger, from 6,000 to 10,000 to 14,000, it's going up, 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 up in our table. Our S values, the number of species, it's also going up, 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 up. What that tells me is that our function is increasing. So what I'm going to do is, by process of elimination, work out whether I should expect a concave up or concave down behavior. So here I am decreasing, so I know that this is not it doesn't have anything to do with our function. Furthermore, I can look on my concave down general graph and I see this is decreasing, so there's no way it has anything to do with my function. Now what we have to do is decide, is my function increasing faster and faster and faster, or is it increasing slower and slower and slower and sort of steadying out? In my table, I go from 40.7 to 47, looking at my S values, to 47.5 to 52. I'm just going to jot a few of these down. 0.5. I've got a 56 point, let's see here, 7 and a 60.2. I think that'll be enough for us to make this determination. You can see in the early values, I'm going up. This is about adding 7 on as I go up by 4,000 in my square miles. My next step of adding 4,000 square miles, I'm going up by only, let's see, it looks like about 5. So I went up by less than I did before. I'm still increasing, but not as quickly. Let's do one more. So from 52.5 to 56.7, that's a little bit under 4, but we're just doing a quick analysis here, so I'm just going to call that 4. You can see in each of these steps, I'm going up by less and less. So this is about 3.5. That means that I am increasing, but at a slower and slower rate. I'm getting less steep in my rate of change. So we've identified that we can expect the graph of S to be concave down. In particular, S should be concave down and increasing. For this next problem, you are told that the given function, called f, has a limiting value. So you're going to notice that as we look through the table of values that represents this function, we're going to be headed towards some specific limiting value. So that's going to be our goal here. We're going to start by putting the function into the calculator using our y equals button. And y is another name for f in this function. That's our function values, our dependent values. And we're going to input the function very carefully with parentheses. Your entire numerator should be written in the first set of parentheses. Then we're going to divide by the whole denominator in a second set of parentheses. And in this way, we make sure we're not just dividing 7 by x, this 7 and this x. If we left the parentheses off, that's what would happen. But we use these parentheses to reorder to make sure we're doing the whole numerator divided by the whole denominator. Once you have that in your y1, you can see that there's a suggestion from WebAssign. It says we suggest starting the table at 0 and using a table increment of 100. That's because we're going to be scrolling for quite a while as we search for this limiting value. So you're going to press second window. Second window is going to take you to the table setup, where we're going to start the table. So that's TBL start. We're going to start the table at 0, as indicated in the problem suggestion, but it's generally a good place to start the table. Then we're going to change the table increment to 100. So that's the change TBL. This is how much your independent variable is going to be changing by in each step of the table. So once you have those filled out, we're going to leave independent and dependent on auto. Second graph is going to take you to the generated table. So that's second graph. Now, I want you keeping up with me, so if you need to, pause the video right now, go put in your function, fix your table, and second graph is going to take you to your personal generated table. All right, so hopefully you've got the table in front of you, and as you look at the values in the X column, you see they're each going up by 100. We made that happen. Okay, we said I want my independent variable to go up by 100 for each step in this table. what I want you to do is focus in on the y values. That's the second column here. And I want you to start paying attention to, do you see some sort of pattern in the numbers? Are we headed towards some specific value? It's probably hard to notice at first. So what I want you to do is just start holding down your scroll down button and just pay attention to what's going on. We start off with numbers like 3.7 something, something, something. We move towards 3.8 something, something, something. Then 3.9 something, something, something. And then we move, all of our numbers then have a 3.99 on them. If you were to keep going, you would see all of a sudden we have more and more nines after this 3. We're getting closer and closer to a value of 4.00. We're trying, it seems as though this function is trying to get closer and closer to its limiting value of 4. So that's actually going to be our final answer on this one, 4.00. Even if it never reaches 4, that's okay. It seems to be limited by 4. So let's say you were way out in your function and you saw a number like this, and that seemed to be your limiting value, because that's a value you can see in your table. What you're really going to do is round that 3.9999, all those nines keep going, you're rounding that to 2 decimal places. So you end up looking at this digit to round to the second decimal place. Since we have to round up, 99 becomes 100 and we end up with 4.00. So that's how we wind up rounding to 4. So even if you just don't know that it's going towards 4, you can look far enough into the table to see a pattern, and then you'd be rounding up to 4.00.